Okay, my dear students, today I will again pick up some previous text to explain it a little bit further. Let me go to exercise 12.1.1 at page 644 from the book by Arfkan. This exercise we have to develop the electrostatic potential for the array of charges shown. Now this we have a minus 2q charge at the origin, plus q charge at z is equal to a, plus q charge at z is equal to minus a. So there are in fact 4 charges with this particular arrangement. This arrangement is called the linear electric quadrupole. So in one of our previous lectures we discussed the electrostatic potential and the electric field due to a dipole, and now let me extend this to a quadrupole. So this is a linear quadrupole. I have solved this problem at page 9 of my notes, which are available with the Photoshop outside the departments. I have told you several times to get these notes. So let me display this over here. This is page number 9, and where I have solved the exercise 12.1.1. Okay, now this is the linear quadrupole, and the total electrostatic potential at a point P distant r from the origin. Well, this is in fact not page number 9, it should be page number let me find out the problem. Okay, this is page number 13 in fact. So let me go to that particular page, page number 13. Yeah, this is the way. So the electrostatic potential due to this combination of charges, as is shown in the statement of the problem, will be 1 over 4 pi epsilon naught minus 2q over r plus q over r1 plus q over r2. So this is the minus 2q charge placed at the origin, which has a distance r from P, and the distance of P from Q on the right hand side is r1, and the distance of the point P from Q at the left hand side is r2. So obviously summing up the potential due to these various charges, we have this equation. And now I have written this by taking q outside, and then now we have 1 over r1, 1 over r2 and minus 1 over r. Okay, now using the cosine law for this triangle, that is the triangle in which we have the angle theta, and we have this minus 2q charge on one corner plus q charge on the other corner and the point P on the third corner. So if we apply the cosine law, we get the value of 1 over r1 equal to r square plus a square minus 2ar cos theta power minus 1 over 2. Similarly, the value of 1 over r2 will be r square plus a square minus 2ar cosine of pi minus theta, because this angle over here for this triangle is pi minus theta. And then we will have minus 2 over r, so which I have written as minus 2r to the power minus 1. Okay, now applying the generating function for the Legendre polynomials over here, after this equation we get this bracket, first bracket, as sigma Pn cos theta a over r power n, the second bracket as sigma Pn cos theta minus 1 to the power n. So I have taken placed minus over here and taken minus 1 power n and a over r power n minus 2. So what I have done here, we have divided the terms in the brackets with we have taken 1 over r as common, so we get q over 4 pi epsilon naught r, and so this is the equation. And then when we expand this series and this series, obviously in this series all the terms are positive, and in this series, as you will see, this factor minus 1 over minus 1 power n will make positive and negative terms. Now after cancelling the positive term of this first series with the negative terms of the second series, we get this equation. Okay, now it is further simplified. You can go through the mathematical steps very easily and reach this result over here, that the electrostatic potential is 2q over 4 pi epsilon naught r Pn cos theta a over r power n. Now for a much less than r, we can restrict to the first term of the series. So if a is much less than r, so obviously this term will be a fraction, and when we take more and more powers of this fraction, we are going to reduce the terms drastically. So let us pick up the first term, which is the largest term, and write this result as 2q over 4 pi epsilon naught r p2 cos theta a over r square. And by putting the value of p2 cos theta, this is the final expression for the electrostatic potential, and this is what we wanted to show. Okay, now let me go to the next page. This is page 13. Now what is on the next page? Let me see. We rotate this first and then zoom it a little bit. Okay, so this is page number 14. I think we have already discussed this page. Okay, now the on the next page, page number 15, we have done few of the verifications, few of the proof which you must go through. However, on page 16 over here, let me show you page number 16. On this page, we have established the orthogonality conditions of the Legendre polynomials. You can go through this page and the next page to show that integral from -1 to +1 of Pm cos theta into Pn cos theta dx is delta mn 2 over 2n plus 1. So go through these two pages to prove the orthogonality condition. This is the orthogonality condition for the Legendre polynomials. Okay, so we have finished with the midterm syllabus by now. I have in today's lecture and in the yesterday's lecture explained in detail few of the steps which are not done in the book, but you should go through my notes and complete these details. So I would suggest you to solve exercises 12.1.1, 12.1.2 and 12.1.3 and 12.1.4 as well. So I have done it. I have done the exercise 12.1.1 in the class, and the rest of the 3 exercises must be done, and you can see the solutions of these exercises from my notes on various pages of my notes. Okay, so that's all for the midterm syllabus. I wish you good luck in the midterm examination, and then after the midterm examination, as directed by the university, we will continue with the rest of the syllabus. Okay, thank you very much.